First, our quick look at the calendar. Today is our fourth and final day on finances. We talk about saving for retirement. And then our last 2 days of new material are on fractals. The project is officially due on December the 9th. And I know that several people have already finished the project, which is great. So the 1 week from today is when the project is due. Questions? Okay, start at the top of page 20. Let's start with Jeremy for number 1. Okay, so last class we talked all about spending. We were doing credit cards. And this class we talk about saving. Chad, too? Okay, let's answer the easy one first. 200 per month. Forget this 6% business, that's the interest, but we just want to know how much she will have invested in 3 years. What do we do? Take 200 and do what? Times the 12 months times 3 years. Yes? Okay, what is that? 72. Okay. Easy enough. She will have invested $7,200 towards her car, but she's been putting this money into an account that's earning interest. So she's going to have more than $7,200 waiting for her when all is said and done. But we've talked about interest formulas before, and we can calculate interest pretty easily. What makes this a hard question? Alicia? Yeah, the amount of money that she has in her account changes every month because she's putting $200 in every month, right? If she just put $7,200 in today and let it grow for 3 years, we have an easy formula that we could answer that question with. But this is tougher, and this is called an annuity because we're making these regular payments on a month-to-month basis. And there's going to be a more complicated formula, but at the moment, all we can say is this one is tough, okay? All right, 3. Stephen. Okay, so the basic idea with annuity is this is the sense of regular payments, regular deposits. Okay, let's go to 4. Sam. Okay, so there's the formula that's going to guide us for today. It actually looks kind of similar to one that we saw last class, the complicated formula we saw at the end of last class. One little thing I'll point out here, that T up in the exponent used to stand for years. In all the other formulas we talked about, T was years. Here, T is the number of payments. So how much is T in this example with Jen with her 3 years every month? 36 is the value of T up there. So you got to do that multiplication to find how many payments there are altogether. And the other kind of funny thing in this formula is that the letter P appears twice, one capital, one lowercase, and they mean completely different things. I'm sorry, it's the same letter. I'm just copying the notation that your book uses. Capital P is the monthly payment. It's the principal. It's how much you put in each month. Lowercase p is the periodic interest rate. That is to say the interest rate per month. So if you have an interest rate of 12% for the whole year, what does that work out to per month? 1%. That's what we're talking about for lowercase p, 1% interest per month. So we use lowercase p here because it's a periodic interest rate. What's the interest rate per period? So oftentimes we have p is equal to little r over 12 because most of the problems we do will be monthly. But more generally, it's R divided by however many payments you make per year. Okay, let's go to 5. Griffin. Okay, let's give it a shot. So this is the magic formula. F is the final value at the end of this whole process. So we're just plugging everything in. Capital P is 200. Bracket, parentheses, 1 plus. Okay, little p is the interest rate, but it's per month. So what do we have to do with that 6%? Right. And that looks an awful lot like something that you saw a bunch last class, 1 plus r over n. We've seen it before. Same idea, just different letters. Okay, capital T is how many payments altogether? It's 36. And we'll just make a note here that this is 12 payments per year for 3 years. That's why there's a 36 up there. No, you don't have to. I'm just in case you look at this document later. And there's a -1 on top. That makes it different from the formula we saw last class where there was a -1 on the bottom. Divided by, what's P? Right, it's that same number divided by 12. Yeah, and then we got to do the calculation. So if you have a calculator, give it a shot. Just parentheses are fine for the brackets. So you can type this in one shot if you're really careful, but it's probably safer just to break it up into different pieces. If you are going to try to type it in all in one shot, make sure you put extra parentheses around the bottom and around the top. Fingers crossed. Okay, so for folks who don't have a calculator, I'll ask this question. How much did she invest altogether? We answered it earlier. 7,200. Is this number reasonable for how much is in the bank at the end? Yes. She made, I don't know, $600 plus in interest. Now, for folks who do have a calculator, you can see this is quite challenging to type in. So again, I'd recommend doing it in bite-sized pieces. It is possible to do it all in one shot. But if you're doing bite-sized pieces, you might do the following. Just the thing in the parentheses. 1 plus 0.06 divided by 12 equals that number. Then raise it to what power? Raise to the 36, that number. And what do we do to finish the top? We subtract 1, that number. Right? And so you can just do this piece by piece, divided by. There's an easy way to get this wrong. We need to hit parentheses here. We're dividing it by 0.06 over 12. Got to have those parentheses, that number. And then finally, times the 200. What did I do wrong? Oh, it should have been 0.06. All right, so we're off by 1 decimal place. That was my way of illustrating how easy it is to make a mistake when you type it into the calculator. You bet. So that should have been a 0.06. I did it wrong on purpose. Yeah, I mean the answer is just that decimal over by 1. Okay, so here's the deal. I'm recording this thing. You have this on video, so I don't want to spend any more time right now playing with the calculators. But you can go through this piece by piece on any calculator that you have, and that's an important thing to do before the test because you're expected to be able to get not just the formula but the final answer on the test. Okay, so 78, 67, 22. Okay, so this is how much money she has at the end. It is reasonable. She invested 7,200 plus a little bit in interest. Okay, moving on to 6, Casey. All right, so at the moment, Jen's investment scheme will allow her to buy a car for $7,800, but she needs to invest more if she wants to be ready with $10,000 at the end of this 3 years. So I think that this number is not helpful at all in answering this question. So I wouldn't start like subtracting the 10,000 minus what she has available. I would just begin right again with this formula, but what becomes the unknown? The 200 now, we don't know how much she needs to invest, and what becomes known is the F. How much is the F? Is the 10,000. All right, so same idea, but just change a couple of things around. So the final value she wants is 10,000. That's equal to some unknown monthly payment P times, and then everything else is the same. Yeah, everything else is the same. Okay, so if I did this right this time, then this thing in the brackets turns out to be about 39 and change. So now I have 10,000 equals P times 39. How do we solve for P? Divide both sides by the 39. $254 and change. Anybody else get that? Okay, so this is about $254.22 instead of the 200 that she had originally budgeted for. So if she can scrounge another $54 every month, she can buy that car of her dreams in 3 years. Questions on this? Evan. That's because I didn't answer the question. Evan, what would you say is the answer to this question? Thank you. Good. In my defense, I'm in like a NyQuil-induced haze right now. So. Yeah, so another $54 and change. Damien? I would like to see that step where you divide, yes. This one right here. Okay. Other questions? All right, so the formulas are getting complicated. Using the calculator is getting complicated. I don't want to spend any more time, again, right here, right now. But when you get to do the activity today, I'll walk around and I'll help people with the calculators. But if you're having trouble getting the right answer on the calculator, don't fret, we can figure it out. But the biggest hint that I can give is to just do it piece by piece, one small step at a time. Don't do the whole thing all in one shot. All right, let's go on to 7, and we're back to Evan. Okay, so let's give this a shot. So we have to weigh 2 different options together. One of them has to do with the technique of today, and one of them is an older technique for us. Which one is the technique today? A one-time payment of 500,000 or 10 grand every 3 months for 20 years? Which one is an annuity? 10 grand every 3 months. That's the regular payments, right? As opposed to the one-time payment. So let's tackle the one-time payment first. Let's see. So 500,000, she's going to invest it in an account that gets 5% monthly. Can you guys find the relevant formula to figure out how much that's worth in 20 years? She's going to put that money in the bank today, and it'll grow for 20 years. Yeah, what's the formula? if you have compound interest, it's this 1 plus r over n to the nt. I forget what letter we use. Was it F or A? F? Okay. Right. That's the formula. I see compound, I think that formula. Unless I see compound with one other keyword, in which case it's a different formula. What was the other magic word? It was continuous. If it's compounded continuous, it's the formula with the E. If it's compounded anything else, it's that formula. Okay, how much is the principal? 500,000 times 1 plus R, 0.05, divide by. N is the number of times interest is compounded per year. It is 12. So we got two separate time periods here. There's the bank interest. Yeah, the bank interest is monthly. And then the exponent up here is going to be 12 times, how much is T? Right now, I think, I think some people are confusing the two things. We got to keep the two pieces separate. Right now, we have a one-time 500,000. It has nothing to do with the every 3 months. It's just 20 years. She's gonna put that $500,000 in the bank one time today, and it's just gonna grow untouched for 20 years, right? So the every 3 months is not relevant to this part of the problem. Okay, so we'll type this thing in. So again, it is possible to type it all in one shot if you're very careful. I'd recommend doing piece by piece. 1,356,000. Anybody else get that? 320. Okay. All right. Okay. So that's how much she could get by depositing 500,000 today and letting it grow untouched for 20 years. We want to compare that to the other option, $10,000 every 3 months for 20 years. Before we do the hard formula, I just want to get a sense of how much money she's going to have coming in. Forget the interest, but just altogether, what is she getting? So this is 10,000 every 3 months. Can you figure out how much money she gets in checks over the course of 20 years? How do we get that? $10,000, and then if it's every 3 months, then that's 4 times a year. So she's going to get 40 grand every year. Oh, times 4. And then times 20 years, right? So she's going to get 800,000 coming in, but it's going to grow, right? And it's going to grow for various amounts of time. The first check that she gets is going to grow for 20 years. But the next check she gets is only going to grow for 19 years and 9 months. And the next check is going to grow for a little bit less. And so it's complicated, but we've got a formula that can handle that. So let's give it a shot. So again, it's this thing here with the F equals. So let's try it. How much is the P? It's 10,000. That's how much we're putting in every time. So P is 10,000. Okay, so F equals 10,000 times, okay, so then it was 1 plus P, right? Now P is supposed to be the periodic interest rate. It's the interest rate that she gets per period. What is it in this case? So it's 5% divided by, yeah, I think that we got to, I don't think we're dividing it by 12 here. Yeah, it has to do with how much interest you get over the course of each period. And there are 4 periods in the year for her in this case. So we're taking that 5% and cutting it into 4 pieces. And then it's supposed to be raised to the t, but it's a different t in this formula. It's not just the number of years, it's the number of payments altogether, which is 80. This guy up here is 80, and I'll just make a note of where that came from. That 80 was really the, every 3 months for 20 years. So 4 times a year for 20 years. What's next in the formula? Is it a -1? And then divided by? 105 divided by 4. Okay, so actually I'll do this in pieces, just like we did before. So again, if you have any calculator issues, you can check out the video. I just went through it, doing it piece by piece, so you can follow it later on. I know it's frustrating to not get the right answer on the calculator. I will walk around later today during class, but at home, if you have any calculator issues, just come back and check out this little piece of the video. So I get 1,361,000. Anybody else get this number? A couple people. Yeah, it can be really annoying to not be able to get the right number, but this is a crazy complicated thing we're typing in. And again, I'd recommend doing it in pieces. But I'll walk around later. Okay, which one is better? Second option. Yeah, second option is just a little bit better. What, 5,000 or so? A little bit better. Okay, aside from calculator questions, are there any questions on this one? Evan. Mm-hmm. Yeah, so the formula that we use is actually this guy right here. The lowercase p is the interest rate divided by the number of payments per year. And so your job was to translate the every 3 months to, oh, that means 4 payments per year. That's what you'd have to do. So that was a part of the formula we didn't highlight, but that's what we used. Okay, other questions on this one? Okay, that said, I will recommend that you never play the lottery. We don't talk about probability in this class, but if we did, then we would be convinced by the end of it to not play the lottery. The lottery is a for-profit institution, even though they say some of the money goes to education and other good places like that. It's a profitable enterprise. If the lottery gave out more money than it took in, it would be bankrupt. But the lotteries are in existence for many, many years, and they're doing quite fine. And it's because they play on people's idea that, oh, I can just invest $1 and I have a dream and somebody's got to win and why can't it be me? And all these nice little catchphrases. But the fact is the odds are very much stacked against you. It is not a good investment. And oftentimes, unfortunately, it's the folks who can least afford to do it that are most desperate. And it's like, hey, this is the only chance that I have to get out of this place that I'm in financially. There are some good books done on kind of the socioeconomic piece of lotteries and how they're actually harmful to our economy as a whole. So if you're interested, you can learn more about that. All right, let's go on to 8. Yeah, what's your name, Ed? Okay. I'm actually kind of confused about the spacing. Do I have different spacing than you guys?
Yeah.
That's interesting. Okay, so it turns out that the 5,000 number is a little bit outdated. It's now 5,500. Is this the next thing, Ed? Yeah. All right, we'll go to Mary for the rest. Assume. Okay, so how many deposits did I make altogether? 10 altogether. 2,000 every time. How much money did I invest? All right, so altogether I invested 20,000. It's a maximum of 5,500 you can put in per year, but you don't have to put in the max. You can put in any amount up to 5,500. So let's suppose that I was able to save $2,000 per year for those 10 years. Let's go to Brandon for B. Okay, same idea, still 10 deposits. How much did Caitlin deposit altogether? It's 10,000. So who's going to have more money when we each retire? Yeah, we don't know. Because even though I invested more, it seems like I should have more at the end of the game. What's the difference between she started investing younger, right? I started investing when I was 34. She started investing when she was 22. So she invested 12 years younger, which is 12 years of interest that she's going to get that I don't have access to because I waited longer, right? We're both going to retire when we each turn 64. But we're going to see what happens to these initial deposits that we make. All right, let's keep going to Aileen. This. Okay, Jake. Okay, so it's a two-step process. We can't just use our annuity formula because we didn't just let the money, we didn't deposit every year until we retired. We stopped depositing after 10 years. So what we're going to do is use the annuity formula for 10 years. We're going to figure out how much money Caitlin and I each have at the end of 10 years. And then we're going to imagine opening a bank account with that one lump sum of money and letting it grow until we retire. Okay? So let's try number 9. It's my scenario again, and we're on to Lila. Okay, let's give it a shot. This is our annuity formula. Starts with a capital P. How much is that? 2,000. That's what we invest each year. 1 plus the interest rate divided by the number of times I invest each year. How much is that? Just once. I'm only investing once each year. And then it's raised to the however many investments I make, which is 10. And then we subtract 1. And then we divide by the 0.07 over 1. So very carefully type that in. I got 27,632. Okay. Again, I'll walk around and check calculators later. But if you don't get it, don't worry about the calculator right now. But let's follow this up now with the next part of the question. Number 10, we'll go to Kate. Okay. Yeah, that's what we're going to start with. So again, this is a compounded problem. So we're doing the R over N formula. Just remember that one. As soon as I see compounded and not continuously, it's that formula. Right? So it's an easy decision-making process for this formula. Okay, what is the principal that we're depositing? 27. It's 27. Multiplied by 1 plus. What's the interest rate? 0.07. N is the number of times you compound every year. Once. Casey, what word in the problem says N is 1? Annually. That's it. How many times per year? Just once. Raised to the N is still 1. Okay, now we got to figure out the number of years here. I said I was retiring at 64. Retiring at 64. I've deposited this money when?
You're 34.
I wasn't in my 30s anymore when I started at 34, but I deposited for 10 years.
44.
So is it? So, all right, so some people are saying 44 is when I make that last deposit. Ed is saying 43. I do it on my birthday.
So you do 44.
I started on my 34th birthday. And then so we started at I'm not below using my fingers today. 34, right? And then we're going to make 10 payments altogether. 35, 36, 37, 38, 39, 40, 41, 42, 43. So I'm 43 when I make that last payment. It's that whole off by one business. Remember in the credit card day last class, we were counting days and we would subtract, like December 27 minus December 20, and we get 7 days, but it's really 8. So it's actually on my 43rd birthday. Okay, how many years are there between my 43rd birthday and my 64th birthday? There's 21 years there. That's a straight subtraction. 64 subtract 43, 21 years. That goes right up there. All right, Daddy needs a new pair of shoes. What do I have? 114,000. That's not bad. How much did I invest? Altogether, what did I invest? 20,000. Okay, so it grew to 114 and change. Okay, questions on that one? All right, so now we've taken care of my retirement portfolio. Let's see how Caitlin did. Same idea, but she's going $1,000 per year and starting at her 22nd birthday. So she's going to stop at 31. Okay, so we begin with which formula? The compound interest or the annuity? annuity, because we got to figure out what happens after 10 regular deposits. So the annuity formula, D is the amount she deposits every time, 1,000. 1 plus. And then how many different deposits did she make? 10, that's up there. Subtract 1. Divide by that same fraction there. 13,816. Anybody else get that same number? Okay. Who had more at the end of the depositing phase? Caitlin had 13. I had what? 27? Okay, so I'm going to win. I have more than twice as much as she does, right? So is it just a clear case I'm going to win? Why not? Yeah, she's got more time. Her money is going to sit in the bank longer than mine is. So we'll now use the compound interest formula for Caitlin, making a one-time deposit of
13,816.45.
okay, and then the 1 plus r over n to the nt. So here's the only difference between Caitlin and I is the t. So 31. So Caitlin, so from her 22nd birthday until when is her last deposit? Her 31st birthday. And then she's going to wait until she's 64 to retire as well. So how many years does she get? She gets 33 years. $128,000. But we're friends. She can loan me the difference or something. So, so I invested twice as much as she did, right? Are you retyping this 45s? Or are you using the answer? Yeah. So it's possible. Yeah, it's possible that as long as you're using second answer, you're getting the most accurate thing your calculator can give. But it's possible that the calculators will give slightly different things because it stores slightly different, like it stops calculating at different places. Like maybe my calculator stops after 5 digits and yours does it after 6. Close enough. But what did you guys get? 09? Really? Did anybody get 09 that had one of the graphing calculators? Damien, what did you do this one? Anybody with the graphing calculator do it? Lila, did you get? No. Okay. Yeah. All right, so let's summarize on the next page while Damien is calculating. How much did Ian invest in total? Yeah, I'm not sure what's going on with the formatting. 20,000. How much did I have at retirement? 415. This. What did I get? How did I get? What? Seriously? What did I do wrong? What did I do wrong? Seriously?
The 13,816. I just put in 5.
Oh yeah, don't put the rounded number. Use the answer. Yeah, right. Okay, how much did Caitlin invest? 10,000. How much did she have at the end? 843.09 or '07. All right. And again, the results above seem to indicate a contradiction. Why did Caitlin end up with more even though she invested less? She had a longer period of time. What's the moral of the story? Start early. I mean, like it makes a difference, even if it's only like 20 bucks a month. I mean, it's the power of compound interest really can make a big difference. Griffin. Mm-hmm. Did they account for inflation? Inflation is something that, well, so first, do people know what inflation is? Who can share with us? What is inflation? Cost of living? Other thoughts? What's inflation? Hmm. Okay, so more money in circulation makes the money in circulation go down. Jeremy, what did you say? Okay, a general rise in prices, but wages maybe not keeping up. Okay. Yeah, so inflation is just a general increase in the cost of living. Um, but it has to be something that's sustained over time. So if we went to the stores tomorrow and the prices were all double what they were today, we'd be upset. But technically, that's not inflation. Inflation is something that has to persist. So if it doubled tomorrow and then stayed there, it's not inflation. It's a gradual thing. And so, maybe your parents or grandparents talk about, oh, when I was a kid and the cost of this and the cost of that. They're talking about inflation because it's a long period that's being covered. So do banks take inflation into account was Griffin's question. Like when they set this kind of thing and you're getting 7%, does that take into account inflation? So nobody knows what inflation is going to be over the next year or even week. So it's really just a gamble. The banks are gambling on one side, and you have to decide whether or not you think that gamble is worth it to you. But inflation is certainly something that will kind of chip away at whatever the stated interest rate is. Generally, people subtract off, okay, I think inflation is going to be 3% a year. So if you're giving me 7%, then really my true gain is a 4% increase. Definitely something to think about. Good question. Um, I taught at high school a bunch of years ago, and I was teaching this pre-calculus class, and we talked about the same kind of thing in investing over the course of a bunch of years, and um, and so most of the kids in the class were 15 or 16 years old, and so I said, all right, so assuming you've put in $1,000 a year every year starting now until you retire, how much will you have at the end? And it was gobs and gobs of money because they were 15 and 16 years old. But the difference in the final amount of money that the 16-year-olds had and the 15-year-olds had was like $500,000 because that it was like over the course of 50 years because they were so far from retiring. And so it was so funny to see these 16-year-olds saying, oh, it's too late. I've waited, my life is over. I've waited too long. I wish I were still 15 and could do this now. Um, all right, so the penny saved activity is here. I will put the flags out and I will come around, raise the flag if you have any calculator questions because we got to get them figured out. So work on this penny saved activity. There should be answers that follow and let's see how far we can get.